Hey, I had a request for problem 5 from the homework, so I thought I would just do a really quick talk through this. This idea, public health officials believe that 90% of children have been vaccinated against the measles. A random survey of medical records at many high schools across the country found that among more than 13,000 children, only 89.4 percent had been vaccinated. A statistician would reject the 90% hypotheses with a p-value of p equals 0.011. So explain what the p-value means. The p-value is always a conditional probability. So you want to remember that. It's the if the null hypothesis is true, the probability of getting results as extreme or more than ours is whatever the p-value is. But you got to put context. So here, if you were doing this problem, you would have made your null hypotheses p equals 0.9 because that's what health officials believe to be true. This statistician, now I chose, because the wording of the problem didn't indicate a direction, so I chose to write it as a two-sided test. I really don't know exactly how it was set up because we weren't really given that information. But so then I would say, specifically to this problem, a p-value of 0.011 means if the true proportion of children who had been vaccinated against measles is really 0.9, that's the null hypothesis, if the null hypothesis is true, then the probability of getting results as extreme or more than ours is 0.011. Now, that's a low probability because remember I said if you're not given a level of, like an alpha level, which you should know about now from your reading, if you're not given an alpha level, then 0.011 is less than 0.05, so we would reject, and actually we're told that he was going to reject it, or he or she. So we would be rejecting the null hypotheses and accepting the alternative, which is to say it's not 0.9. So because the probability is low, we would reject the null hypotheses and say that the true proportion is different than 0.9. That's what it means to be statistically significant. When your p-value is low enough that you do not think those results could happen by chance alone, and then you are doubting the null hypotheses claim. Because it would be so unlikely to happen by chance alone. That's statistically significant. But then in part B, they say, okay, so the result is statistically significant, but is it important? Comment. We're talking 90% compared to 89.4%. Is that really that important? And is it much of a difference? And so sometimes you can get results that are statistically significant, but it's not practically important. And that can tend to happen in this situation right here. We have a really large sample size. And when you have a really large sample size, you can sometimes end up getting something that's statistically significant, but it doesn't have practical importance. So you want to kind of watch out for that. And that was one of the things in the reading in chapter 21. So I hope you're doing that reading that kind of gives you that information. So hopefully this helps.